We will begin our examination of three-phase electricity by first looking at one complete cycle of AC current. Notice that one cycle of electricity consists of 360 degrees, which can be divided into two 180-degree divisions called alternations. The first half cycle is the positive alternation, and the second half cycle is the negative alternation. As you can see from this simple illustration, the current flows in one direction for one alternation, and then flows in the opposite direction for the second alternation. Also notice that the voltage potential constantly changed values as the sine wave went from 0 to maximum positive peak and back to 0, then from 0 to maximum negative peak and back to 0 again to complete one cycle. Here you see the AC sine wave being illustrated with a bicycle pedal used to illustrate the 360-degree cycle. When the front pedal is between 0 and 180 degrees, the pedal is in its positive power portion of the 360-degree cycle. When the rear pedal, behind the sprocket, reaches the 0-degree point, it produces the negative power portion of the 360-degree cycle. The power portion of the 360-degree cycle be considered as that part of the cycle which causes work to be done. On the AC sine wave, the power portion of the alternation is that part which is either above or below the 0-volt reference line. On the bicycle pedal illustration, the power portion is that part of the complete cycle in which one of the pedals is being pushed down. As you can see, when one pedal is being pushed down, the other pedal is being returned to the 0-degree point. The return pedal stroke is not supplying power during its portion of the cycle. Now suppose that we use three of these waveforms working together to supply electrical energy into a circuit. Notice, in this illustration, we are showing three identical waveforms. They all have the same amplitude, frequency, and phase. In order to make these three identical AC sine waves work together in their most efficient manner, we must separate them by equal amounts. Since a complete AC cycle consists of 360 degrees, and we need an equal separation between the three AC signals, we will need to separate them 120 degrees from one another. Notice that phase A starts at the 0-degree point and completes its cycle at 360 degrees. Now notice that phase B starts 120 degrees from the phase A sine wave and completes its cycle at 480 degrees. Phase C, on the other hand, starts 240 degrees from phase A and completes its cycle 600 degrees from the start of phase A. To illustrate the effect of three-phase electricity, we will use three sets of bicycle pedals. Each pedal is set 120 degrees from the other two pedals. As you can see, the front pedal of phase A starts at 0 degrees, the front pedal of phase B starts at 120 degrees, and the front pedal of phase C starts at 240 degrees. Now let's compare these pedals to a three-phase sine wave. As you can see, the sine wave for phase A starts at the 0 reference line and then increases to its positive peak potential. When compared to the start of phase A, phase B is actually 120 degrees into its cycle. And when compared to the start of phase A, phase C is already 240 degrees into its cycle. Here you see all three phases operating simultaneously. Notice that at any given point in the three-phase cycle, at least two of the phases will be working together to provide power into an electrical device. Since the phases are all separated by a 120-degree phase shift, the return current from one leg will feed back through one or both of the other legs. With all three phases operating, it is much easier to cause the armature of a large AC motor to rotate, due to the fact that three 60-cycle AC currents are working together to cause the rotation. Another major benefit of the three-phase system is that it is much easier to rectify into direct current. As you can see, three-phase electricity is not that difficult to understand. However, you should know how it works because it is used extensively throughout the manufacturing industry due to its ability to produce more usable power than can be achieved through the use of single-phase electricity. Many of the larger AC and DC servo motors use three-phase electricity as the incoming power source. Also, many of the larger AC motors used in servo systems operate from a variable frequency AC power source. You will learn more about this later. Now let's examine the operation of the AC motor.